It's a visualization that shows lake effect snow and how it occurs in northwest Indiana and Michiana. Key ingredients here. First off, we have to have cold, dry air. That's going to be from a continental polar air mass, or even colder, even drier, an Arctic air mass that could be coming from the north and from the west. What we then have to have is we have to have a large enough water body. And it has to be typically at least 50 miles. So not something, the lake outside, maybe the retention pond in your backyard or down the street. This is a big lake. And so Lake Michigan, perfect characteristics. All of the Great Lakes are perfect characteristics of the large enough lakes for lake effect snow. And so what we also need is that lake to not be frozen. And so that means it's going to be relatively warm. And so you see warm in quotations. It's because warm is compared to the outside air. And so we have outside air over land. And so the lake, it's very sluggish to heat up, but also cool down. And so for that reason, you'll see September, October, November, December, the water will actually have will hold on to its temperature longer, and so it'll be slower to cool down, where the land obviously cools down much quicker. So you have to have a certain size lake. Further, you have to have a prevailing wind, and so if the air is just stagnant, then you're not going to have this uplift. If the wind's moving too fast, then you're not going to have enough time for the warm lake to then create the cloud formations. And so it has to be the perfect speed in terms of wind. So what we have is they have a cold, dry air mass that's moving across, let's say, Chicago and Wisconsin, and comes across Lake Michigan here. And the lake is, once again, cold, but warmer than the surrounding area. So we're going to get steam fog as we get the uplift occurring. And so now we get this moisture, this warm, moist water body that's get the uplift, and so now we get a little bit of condensation, so you might start to see some steam fog. Notice where this fog occurs. It doesn't occur over here in Chicago, Wisconsin. It occurs here in the middle, and then as we get the perfect conditions, the clouds get taller and taller and taller. Eventually the ice crystals can't be held aloft, and we have a dumping of snow over here on the leeward or the downwind side of the lake. And so then South Bend gets all the snow from this situation. Here's a radar loop from January 1st, 2012, in which you can see this particular pattern. Notice where the cloud formation is occurring. Not over here in the western side of Lake Michigan, but over here because the prevailing winds are coming from the northwest to the southeast. And so it's coming perfectly across Lake Michigan, where, guess what, South Bend? You get all the snow. And so you can see how this huge dumping of snow wouldn't exist if not for Lake Michigan, in which we have that warm water body, in which we have that lake effect precipitation being formed. And we see the snow totals from this particular lake effect snow, and you can see right here, if you don't know your counties, that South Bend is pretty much right there. And so South Bend got hit the hardest. And you'll notice that right here along the lake, not so much. And so right here along the lake, there was some snowfall, but as far as that uplift and all those ice crystals forming, we really saw that happening just off the lake. And so that kind of goes back to this schematic, this visualization here. Let's look at another one. This is from 2013. So you can see kind of a different area hit, more down here. So St. Joseph in South Bend for sure, but also now we see more of an impact here in LaPorte County, Michigan City, for example. And the snowfall totals there. You can see how we see this dense band all along the eastern side of Lake Michigan. All of this is lake effect snow. Here's another one in which you can see as far as the direction matters. And so previously we saw the wind directions were kind of moving in this particular pattern, coming across, and so perfect for South Bend. Now let's say we have a more northerly wind pattern. Here, we're going to see a lake effect snow affect a different area. And so this is going to be the Portage Valparaiso area that are going to have the highest totals from this particular lake effect snowstorm. Whereas over here, South Bend, they got nothing. And so this is a good example of how direction matters in terms of the directions that the prevailing upper level winds are moving, and moving thus this lake effect snow fall onto the land, in this case, onto Valparaiso instead of South Bend. Finally, I like to show this map because it shows South Bend and all of that, but look at Fort Wayne. little bit of snowfall, but this is why South Bend gets so much more snowfall than Fort Wayne. Latitudinally, they're not that far off. Elevation-wise, not too far off. But when we look at where they are as far as proximity to a water body, of course, South Bend closer, and it's going to be more impacted by lake effect snow.